In this video, we will review the substructure enhancements in the latest release of OpenBridge Modeler, namely inverted T-caps to follow crown slope, cheek walls to follow chamfer or fillet of the cap, bearing seats to follow cap skew and cap end treatment, separate levels introduced for bearings, decorators and text, capability to define individual pile rotation angles, and minimum and maximum properties introduced as limits for parametric cell variables. The first enhancement with substructure elements is the inverted T-type caps to follow crown slope. The crown deck option for cap top slope was introduced in the previous release, the second release of 2021, but not for inverted T-type caps. In this release, top of the inverted T can also follow the crown slope if the top slope is set to crown deck in the cap tab of the elevation constraints dialog. If the deck has multiple slopes, the top of the inverted T can also follow that and its bottom will be leveled. In OpenBridge Modeler, the cap top slope for this pier with the inverted T cap is set to level initially. To apply this new option, I will go to Properties, open the Elevation Constraints dialog, and in the cap tab set the top slope to crown deck. The bottom slope option will disappear, so cap bottom will always be leveled when this option is selected, and after clicking OK, the top of the cap will start following the slope of the crown deck. If I change the deck template to one with multiple slopes like this one, where the slope changes from one lane to another, the top slope of the inverted T can also mimic that and follow different slopes. The second substructure enhancement is the new capability of cheek walls to adjust the chamfer or fillet of the underlying cap. In previous releases, cheek walls were always drawn rectangular. Now they follow the chamfer or fillet option specified for the cap ends. To apply this new feature in OBM, I will use this pier with the rectangular cap with no end treatment. Through the properties of the pier, I open the substructure template, and in the cap tab I will set the edge property to chamfer instead of none and specify the chamfer length. Then switch to the cheek walls tab, add a new cheek wall to the right hand of the cap, adjust its width to the width of the cap, and define the length at the bottom and top. The graphics view on the right will not update, but when I click OK and accept the changes, the ends of the cap and the cheek wall will take the shape of the cap at its end and be chamfered. The same applies to filleted cap ends, so if I go back to the substructure template dialog, set edge to fillet and enter the fillet radius, the cheek wall and cap end will be filleted instead. The next substructure enhancements are with the bearing seats on abutments and piers. With the model step gap property set to true for skewed supports, if apply skew to solids option is set to true and faces of the bearing seats are adjusted to follow the cap edges, or if the ends of the cap are chamfered or filleted, the bearing seats are adjusted to follow the end treatment of the underlying cap. To illustrate this in OpenBridge Modeler, I will use this pier with step gap. First, I will set the skew angle for the pier support line to 20 degrees. Now that the support is skewed, I will change the apply skew to solids property to true. The end faces of the pier cap start following the deck edges, and now so do the bearing seats. For the second enhancement with bearing seats, I will open the substructure template dialog for the pier, and in the cap tab I will set the edge definition to fillet and specify the radius. And the bearing seats are filleted, taking the shape of the cap ends. Similarly, if the cap ends were chamfered instead, the bearing seats would be chamfered as well. Another enhancement related to bearings is the separate levels introduced for bearings, decorators and text. Previously, all of the text and the bearing decorators at elevation 0 were drawn on the same level, so it was not possible to turn off the display of the text only. Now, since they are on separate levels, bearing lines text can be turned off while still displaying the lines themselves, allowing more flexibility in terms of plans production. In OpenBridge Modeler, the level for bearing lines is named OBMD bearing group, and the level for bearing lines text is OBMD bearing group text. At elevation 0, to keep the blue dashed lines representing the bearing center lines but remove the text for the bearing group, in the level display dialog I can turn off OBMD bearing group text and the text will disappear. And OBMD bearing group controls the bearing lines. I can repeat the same in the 3D view. These will appear at elevation 0 in view 3. Again, through level display, I can turn off bearing lines level, OBMD bearing group, and the text level, OBMD bearing group text. An enhancement with piles is a new capability to input individual pile rotations. Previously in OpenBridge Modeler, it was not possible to model the complex cases where piles are at different angles. A single rotation angle could be assigned to all piles of a footing. Now it's possible to specify the rotation for piles individually in the manual table of the Pile Pattern Layout dialog. This can be done through the abutment or peer libraries or the substructure template of the support after placement. For this peer, I will go to Properties, then Substructure Template, and in the Piles tab, if all piles share the same rotation angle, then it can be defined through this rotation field. If piles will be at different angles, I can click on the Pattern Layout button. It brings up the Pile Pattern Layout dialog, and after activating the table by flagging the manual option, rotation angle can be input for each pile through the rotation column. I will set the rotation to 90 for the first two piles at the top, and the graphics view here will be updated instantly. If multiple changes need to be made in the table, the information here can be copied into Excel, and after making the necessary changes, it can be pasted back into OBM. So I will select all rows in the table, right click and choose copy. Then in Excel, I will paste this information, set the rotation angle to 90 for the first 8 piles, copy all rows, and back in OBM, right click and paste. And all piles in the top row will be rotated 90 degrees in the graphics view. I click OK to accept. In the Substructure Template dialog, I can view the resulting piles by changing the orientation to top and display mode to wireframe. When I click OK, the peer will be updated with the new pile orientations. The piles at the top row will be rotated 90 degrees from the default orientation. Finally, the last enhancement with substructure elements is the new minimum and maximum properties assigned to parametric cell variables to avoid errors. A minimum and maximum can be set for the value of a variable of a parametric cell, and if a lower or higher value is input, then it automatically changes to the limit. For this XPR, minimums and maximums can be specified for any variable. As an example, for variable footing height, minimum can be specified as 3 feet and maximum as 8 feet. And with these limits, if active value is set to 10 feet, it will be automatically changed to the 8 feet. And if 1 feet is entered for active value, it will be updated as 3 feet to meet the minimum value.